The temperature, like it's mostly Earth-like, within the altitude of 50 to 65 kilometers. The temperatures is more Earth-like, like 30 to 40 in summer, and -1, -2 at the winter. It would be nice to live on Venus. Like it would be pleasant to live on Venus, and it may accommodate thermoacidophilic, extremophile, and microorganisms in the acidic upper layers of the Venusian atmosphere. Like I told you, it would allow some microorganisms to like stay or accommodate on the Venusian atmosphere, the uppermost of the Venusian atmosphere. Furthermore, Venus likely had liquid on its surface for at least a few million years after its formation in September 2020. Now it is the it's telling that Venus would have had a life for at least a million years for at least million years. A paper was published announcing the detection of phosphine in Venus's atmosphere in concentrations that, meaning, a paper was published that phosphine, or a chemical which is essential for life, was found there on Venus, and it surprised the astronomy world and tried and everybody tried to go more research and about Venus. So that's all about Venus. Let's move on to Ceres, the only dwarf planet in the asteroid belt and the only dwarf planet which is big in the asteroid belt, has a thin water vapor atmosphere. The vapor could have been produced by ice volcanoes. You might have been seeing fire volcanoes or magma out of the volcanoes, but in the cold temperatures in the asteroid belt, it would be some ice volcanoes, or by ice near the surface sublimating, transforming from solid to gas. Nevertheless, the presence of water on Ceres had led to speculation that life may be possible there. As I told you, the eruption of the ice volcanoes releases ice, and the sun heats it when it's the daytime on one side of the Ceres. The sun's heat it, and it goes into a gas because the atmosphere is not there. If if the atmosphere was there in Ceres, then it would be like we can go there anywhere, space time travel. But now also we can go to Ceres, but it would be shortage of water, because the ice suddenly melts into gas without going to into water form. For going into water form, it should have a thick atmosphere, like not thick atmosphere, the atmosphere like Earth, like nearly one. It is the one of few places in the solar system where scientists would like to search for possible signs of life. Although the dwarf planet might not have living things today, there could be signs it had harbored life in the past, like the Mars. The series is not concentrating now. We are concentrating on Mars, like SpaceX and NASA are going there, as you know. But series would have, if they like go in deep dive into series or send some people to series, or spacecraft like messenger go to Mercury. Like if they follow that method, it would be not that detailed, but okay. But if they send people into series, it would be like more detailed. Now next is Jupiter. Carl Sagan and others in 1960s and 1970s computed conditions of for hypothetical microorganisms living in the atmosphere of Jupiter. Again, the same of the Venus, same. But Jupiter is a gas planet, gas giant, so it doesn't have an atmosphere. Hypothetical microorganisms living in the atmosphere of Jupiter, the intense radiation and other conditions. As you know, Jupiter has very intense gravity, like more even than Earth. If you step on Jupiter, you'd be mushed, like somebody pushing you on both sides. However, do not appear to permit encapsulation and molecular biochemistry, so life there is thought unlikely. In contrast, some of the Jupiter moons may have habitats capable of sustaining lives. Scientists have indication that heated subsurface oceans of liquid water may exist deep under the crust of three outer Galilean moons, Europa, Ganymede, and Callisto. Now, in Jupiter, they thought it won't it won't form. The life wouldn't form in such an intense radiation and other conditions were, like I told, like gravity. And they thought we'll research about Jupiter's moons like Europa, Ganymede, and Callisto. The EGSM or LAPES mission was planned to determine the habitability of these environments. However, due to the lack of funding, the program was not continued. Similar missions like SRJUICE and NASA's Europa Clipper are currently in development and are slated for launch in 2022 and 2024 respectively. Okay, that's about Jupiter, and let's move on to Europa. Internal structures of Europa. The blue represents subsurface oceans, such as subsurface oceans could possibly harbor life. Jupiter's moon Europa has been the subject of speculation about the existence of life due to the strong possibility of a liquid water ocean beneath its icy surface. Hydrothermal vents on the bottom of the ocean, if they exist, may warm the water may warm the water may warm the water and could be capable of supplying nutrients and energy to the microorganisms. It is also possible that Europa could support aerobic microfauna using oxygen created by cosmic rays impacting on its icy surface. The case for life on Europa was greatly enhanced in 2011 when discovered the vast lake exists within Europa's thick icy shell. Scientists found that icy shelves surrounding the lakes appeared to be collapsing to them, thereby providing a mechanism through which a life forming chemicals created in sunlit areas on Europa's surface could be transmitted to its interior. On December 11th, 2013, NASA reported the detection of clay-like minerals, specifically phyllosilicates, often associated with the organic materials on the icy crust of Europa. The, the presence of minerals might have been result of a collision uh, with an asteroid or comet, according to the scientists. The Europa Clipper, which would assess the habitability of Europa, is planned for launch in 2024. As I told you in Jupiter's slide only, Europa's subsurface ocean is considered the best target for discovery of life. Now, this is also a bit detailed, so I'm gonna just like tell you like a sneak peek like that. Okay, the internal structure of Europa, the blue represents a subsurface ocean, meaning such subsurface ocean could be possibly harbor life. Europa has been the subject of speculation about the existence of life. As you know, liquid also contains water and all the things needed for life. Now, you take an example of us. If we don't drink water for too many days, it would be lack of oxygen and another minerals which are in water, but in that water, but not on our body. It is like giving us some minerals which uh, which are needed for life, like that only. If you don't drink for like 10 days, you would possibly die, or it depends on the how healthy you are. But okay, that I'm not thinking. But I'm telling that the subsurface ocean contains some minerals that are okay, and like are the conditions to contain life on our planet. It is below the crust. No, though it is below the crust, and it almost goes down the mantle. Almost goes down the mantle. It the crust. If we dig down, we get water. Like that only it would be. Hydrothermal vents on the bottom of the ocean, if they exist. Hydrothermal vents meaning the water coming from a vent, like it would be like a volcano like structure, and it would be short, but I'm not telling that it would be tall. It would be short, and some bubbles coming out of from it. It's called hydrothermal vents, and it generates a lot of heat. It generates a lot of heat, that it life could exist. Hydrothermal vents. Speaking of hydrothermal vents, Luca, Luca meaning uh, last universal universal ancestor, common ancestor, that is called Luca. It generates from the hydrothermal vents. I mean, that originates from the hydrothermal vents. Slowly, that Luca goes into some forms like flatworms, and goes more to monkeys and human beings, maybe. Okay, and and also possible that Europa could support aerobic microfauna using oxygen created by cosmic rays impacting on its icy surface. The case for life on Europa was greatly enhanced in 2011 when it was discovered that vast lakes exist within Europa's thick icy shell. Scientists found that icy shelves surrounding the lakes appeared to be collapsing into them, thereby providing a mechanism through life forming chemicals created in sunlit areas. Now, in the lake where there is sunlight,